Oh, thank you. Glad to know that. So last week we've covered um, quite some bits of SQL. So taken by my amiable boss here, Said. So he has covered the basics of SQL, at least, and we are still covering the basics. So the select statement, select from where. He also covered functions, the different types of functions. So, but today we'll be talking more about numerical functions and how we can use some keywords in relation with numerical functions. All right, so let me share my screen, please. I think you guys can see my screen, right?
Yes.
Yes, sir. Your feeling is visible, sir.
So that is great. Happy to know that. Let me put it on full screen mode. So we'll be talking about aliasing, um, distinct and having keywords. So aliasing is just a process in SQL. So then we'll also cover two keywords, distinct and having. So, but I'm going to start with the keywords. Okay. So please feel free to interrupt me as the session goes on. If you have any questions, please do well to ask. All right. So before we move ahead, let's first of all talk a little bit more about numerical functions. So I also wanted to point out that numerical functions can be categorized into two. So we have the aggregate functions and we have the scalar functions. So it's important for you to be able to differentiate these two types of numerical functions. Okay, because that will help you to know how when you are to use the keywords that we are going to talk about today. So examples of aggregate functions are minimum, the min function. So from the name, it helps you to identify the minimum value in a column. Then we have max, which helps to identify the maximum value. We have the AVG function to calculate the average of the entries, sum and count. Sum to add everything together, count to count the number of values there. So, but how do aggregate functions work? So what aggregate functions do is they run through the values in a particular column and give you a particular value as your output. So they give you a column-wise output. Okay, so that's why I have the example here, as you can see on my screen. So let's say we have in our database or in our table, we have the age column, and these are the ages. Then you now pass in this function to SQL, AVG of age. So that means you want to find the average age. So it's going to give you a single value, 40, which summarizes this whole column. Okay, and the summary in this case is you are calculating the average. So these functions summarizes a column and gives you a particular output. That is unlike the scalar functions. The scalar functions go through the columns and give you row-wise outputs. Okay, so you get outputs per row, not a single output for a particular column. So we see the example of round. So round is to round off a number. So we have the H colon again, and I pass in the round. I pass in the round function. I pass in the round function on H, and I put comma 0. So this 0 is the number of decimal places. Okay, I want it to round off to. So I want it to round off to 0 decimal place. So that means I want my edges to be in whole numbers. They should be whole numbers. I don't want any. They should be integers. I don't want decimal places. So you can see that that now gives you output per row, not a single output for this column. So that's the major difference between how these functions work and this function work. I don't know if there's any question to that. There isn't. I'll move on. So now we're going to talk more now on the distinct keyword. The distinct keyword. So you can use that distinct keyword with the select statement, or you can use it with the count function. Okay, so you can use distinct with select statement or with count function. So when you use distinct with select, the purpose is to eliminate duplicate rows from the results of the query. So you want unique values from the results of the query. So that's an example here. So we have select distinct department. This is the column name, department, from the employees table. So what will this one give us? This will give you the different departments that are in the employees table, like the different unique departments. So it's not going to just return the department column as it is, but what it's going to do is that it's going to select the unique departments in that department column. So I hope to understand that. So that is how select distinct works. So, but when we now use it with the count function, we use this syntax, count into brackets, distinct, then the colon name. This is used to count the number of unique non-null values in a column. Okay, so we have an example here now. So if we have select count distinct departments from employees, what this will do is to return the number of different departments that are in this department column. So while this one will show you the names of those departments. So if there are 5 in number, then this one will give you the number, which is 5. Now let's move on to having. So I want us to just go through all the theory before we now move on to the practical. So we'll be able to apply what we have learned. Okay. So we're also going to move to the practical soon. So this next one is having, the having keyword. So that this is the reason why we have to quickly go over aggregate functions, because you use having with aggregate functions. So having is like where clause. So last week we covered where clause. Who can remind us what where clause does in a SQL statement? Quickly.
To filter.
To filter, right? Thank you so much. To filter. So, but you see that where can be used to filter based on a particular column in your table. So if you look at the syntax, now, you notice that we have my select statement. I'm selecting column 1. Then I'm not applying an aggregate function on a particular column X from a particular table. Now, remember that when you have a colon and a function, you have to use the group by function, and you group by the particular column of interest, which is in this case is column 1. Now, this is where having now comes in. You now write an having condition based on this function. You are not filtering based on this column, but you want to filter based on this function, then you use having. So it's possible that in your query, you're able to combine all the keywords that we have mentioned so far in this Launchpad. So we recall that Said had already covered select, from, where, group by, and order by. Now we're also talking about having. But how do you now write the order of this code? Because the order matters. Okay. So you start from your normal select from where, which is a normal SQL syntax, then followed by group by before you have your having. Then lastly, you now have your order by. So the where clause serves like a pre-filter before the aggregate function is carried out on your data. So this is how it works. Okay. So this is how it works. So if you have this kind of query, first of all, the SQL finds out every entries that satisfy the where condition. That satisfy the where condition. Okay. So when it's able to select all the entries that satisfy the where condition, it groups them. It groups them, then applies the aggregate function that you have in the select statement on them. So after applying the aggregate function on each group, then it now filters using the condition on the having keyword. Okay. So after doing that, then to combine all your outputs together, it now orders by the colon that you have in the order by. So order by can be used for colons, order by can also be used for aggregate functions. So that is why this is the order in which you are supposed to write your code. We are going to see some examples as we do the practical. Then lastly is aliasing. Now, what is aliasing? Aliasing is the process of temporarily renaming a table or column within a table. So aliasing is a very key process in whatever code, SQL code that you are writing. And no matter the function you are dealing with, whether you are dealing with numerical functions or other functions, aliasing is always key. It's helpful. It's not compulsory for you to do it, but sometimes it is necessary to do it. And we're going to cover why. Then, but one thing we need to keep note of is that it does not change our database and it can only be executed in the current query. So that means that you cannot use that alias in another query. It is only in that singular query that you can use that alias. So that's why we call it a temporary renaming. Okay. So if you want to alias columns, you use the as keyword. Use the as keyword. Though in MySQL, it's not compulsory for you to use the as keyword. You might not use it. So let's say I want to give this column one an alias. So I just write select column as a particular alias name from a particular table. Also, you can alias tables. So most times for tables, we don't even use the as keyword. We just write select column from table followed by his alias name. So aliases are helpful in enhancing code readability. It makes code easier to read, especially when you have a lot of functions or you are doing quite some calculations in your SQL. These aliases can help to make your code more readable. And when you join tables with similar columns, you just have to use aliases to make it more readable. For example, let's say you have two tables, employee table and sales table. And both tables have employee ID. Okay? Because both tables have the employee ID. So you might need aliases to be able to differentiate that of the employee table and that of the sales table. All right. And also, aliases are helpful when the query is lengthy and it takes a while to type out. So you can use it like a shorthand for your queries. Sorry. Okay. But we need to note some things when using aliases. Number one, we want to avoid space-separated aliases, like this example here, number of customers with space. Want to avoid that. Then also avoid aliases that start with a numerical character, say 3_departments. No. Then aliases should be meaningful. So for example, if you have a column that is titled age of customers and you want to give it an alias, you can just simply use customer age, customer underscore age. That's meaningful. It's something that when somebody sees, can easily use. Though sometimes we might use a single letter to alias, most times tables, but sometimes it's also best to use meaningful aliases so that when somebody is reading your queries, the person understands what the alias stands for. So remember, when we're writing SQL queries, we're not just writing for ourselves alone. We're also writing for others so that when others see our queries, they will understand what we are doing, what the query is all about, and probably be able to move on from there. Because most times we work as a team in the tech space. So our codes have to be readable and intuitive for others. So that's it with the theory aspects. Now we're going to move to our MySQL. Please let me know if you can see my screen and you can hear me audibly.
Yes, can hear you. You can see the screen.
Oh, thank you very much. All right, so we're going to take some examples on these different categories that we have, or the different statements or keywords rather that we have considered today. But I also thought of I've also thought of bringing up questions that we are trying to answer through our SQL query. So you see, when you work with SQL, you are like a detective, okay? A data detective. So you are trying to get evidence from your data. So, and as a detective, you have some questions. Why is this? What happened at so time and things like that. And you now do your search to find the answers to those key questions. So it's the same thing too with working with SQL and even analyzing data altogether, because you don't just want to just be playing with your data. No, you will have some objectives in mind, okay, or some business problem that you want to solve. And it, it is these things that is going to determine how you are going to, the analytical process you are going to carry on your data rather. So the first question that we have here is, what are the customer loyalty tiers? So I have actually opened up, okay, so let me run each of this so that we see the different tables that we have in our database. Let me comment this. All right, so we have the product table. So it's good for you to be conversant with your data. Know, at least have a good sense of what your data is about. So in the product table, we have the product ID. Definitely that is identifying each product that we have. Then we have the name of the product as product name, the category, that means they've been categorized. Then we also have subcategories. We have the price of the product, which is like the selling price. Then the cost price of the product, how much it takes to manufacture or to buy that product or to stock it. Then we have the launch dates. So the launch date is when that product was launched. Then discontinued. Have we discontinued that product or it is still in the market? So that is for products. Next is order. So customers come to order these products. So we have the order ID, we have the customer ID, the particular customer that ordered, that made the order, the date at which the order was made, the status, whether it is delivered or not, and the payment method. Let me just go on to other items first, since it's related to orders. So in the other item, we now have the item ID, the order ID, so relating it to orders. So I'm sure Said had talked about primary key and foreign keys that are used to relate tables, because this is a relational database. So there are always colons in each table that you can use to link the tables together. So which in this case, we can link orders and other items using the order ID. All right, so these are the order ID, the product ID, to link it to the products table. Then we have the quantity that was ordered, the unit price, and the discount. So sometimes discount is given for a particular order. Then now let's move on to customers. Okay, so we have the customers table, customer ID, which is a unique identity for the customers, the first name of the customer, the last name, the email, join date when the customers started patronizing us, the city from which the customer comes from, the state that city is, and the country that state is, then the loyalty tier of that customer. Then lastly, we have the returns table, which contain the return ID, the order ID. Now, this order ID is important because we're talking about this return table is trying to capture why some products were returned. So, so we have the return date, the date in which the product was returned, the reason for the return, and the amount that was refunded, or the amount that is to be refunded, or that was refunded. So, depending on the information that we have about this state. So these are the 5 tables that we have in our database. So, which table do you think will be able to help us answer this question? What are the customer loyalty tiers? Which table? I would like this session to be interactive. We are interested in the customer loyalty tiers. So which table will be able to help us? Is it the products table? You can quickly look at the column names. The orders table. The customers table. Other IDs, other items rather, or the returns table. Which one? Anybody?
The customer table.
The customer table, why? Why the customer table?
Because it has the column loyalty tier.
Excellent. So it has the column loyalty tier. So wisdom, do you agree with that?
Yes.
Yes, I agree with
The
you
customer,
guys too. Yes, the customer table. So I can just copy this because I'm selecting from the customer table. So let me come to my query. So I'm selecting from my customers table. All right. But I need what? The loyalty tiers, right? So I just pick the loyalty tier column. So I want to select the loyalty tiers column from the customer table. Okay, sorry, am I getting the spelling right? Let me check. Okay, loyalty tier is singular. All right. So can we see our output here? So what these have done is just to bring out, so if I go to the customer table, so this column here is just displaying this column. As well, we're just interested in the different tiers that we have for each customer. Okay, so we don't just want to see the customer loyalty tier column. We want to see the different tiers. This thing, by the unique loyalty tiers that we have. So let me run this. And here we go. So we see that we have 4 loyalty tiers: silver, platinum, bronze, and SQL. See this icon here that looks like a brush? It says beautify / reformat the SQL script. So if you click it, you now put your code. Spaces and the indenting do not affect the SQL program running. No. So, but just for readability, that is why we use this icon. So I guess we have been able to answer that question, right? We have been able to identify the customer loyalty tiers that we have. So the next one is, are there duplicates in my customer data? Are there duplicates in my customer data? So that means we're talking about the customer table. I want to identify if there are duplicates. So first of all, I need to check how many rows I have. I need to check how many rows I have in my customer table. So I can just copy this. Okay, now I think I've copied it before. Select here on customer. So if I do this, this will just select everything in the customer table. But I want to count the number of rows. So I use count. Count asterisk means count all. So I want to count all the rows in all the columns. This will help me to be able to identify the number of rows that I have. So let me run this. So running it, I have count asterisk to be 500. So that means I have 500 rows. But as you can see, the count is not looking fine here. Look at the output. Count asterisk is not looking fine. So you can use an alias there as num rows. So like saying that this is the number of rows that I have. So let me run that again. Aha, and now it's looking better. Num rows is 500. The number of rows is 500. Okay, so this is just the number of rows in the data. But to be able to know if there are duplicates in my data, then I can use the select distance and still count. Okay, so I'm doing everything here. Let me copy this instead of typing everything. I'm doing everything here, but I am just including this thing. So I'm going to compare this answer that I'm going to get from this query with this one. That will help me to be able to know whether they were duplicate, because this one will remove duplicate because of the distinct keyword. So let me call this output number of non-duplicates. So I'll just call this non-duplicates. So I want to know how many non-duplicates I have in my data. So I'm going to run that. So the number of non-duplicates is also what? 500. So with the results from the 2 queries, it shows that there are no duplicates in my customer data, because When I counted all the entries in my data, I got 500. When I also counted the unique values in my data, I still got 500, meaning that every row is unique. So meaning that there are no duplicates. Is there any question? Okay, so let's go on. The next question is, what are the unique reasons why customers return products? So we want to identify the unique reasons why customers return products. Which table will be able to help us answer this question?
Returns.
Returns. Okay, let's go to returns table. Why?
The reason column is there.
Yeah, the reason column is there. Thank you so much. So let me just copy this and go to the query. So that means that which column do I want to select then?
Reason.
Yes, reason. So I'm selecting reason from the returns
Is it reason
column.
or reason?
So let's check again. So it's reason, it's single.
Reason.
So reason. So let's run this. Yeah, so we're selecting. So when you just select the reason column, you see you have the whole reason column. But the question is, what are the unique reasons why customer return products? So we want to identify each of the different reasons that we have. So what am I going to use again? To be able to identify the unique reasons. Or what am I going to introduce? Yes, I just put in distinct here and style it better. Then run. And we have the unique reasons why customer return products. And there are some people return because it's no longer needed, others because the product is defective, others because it's a wrong item, still others, they change their mind. And lastly, those who return because of late delivery. Okay, so you see how powerful the select distinct is. No matter how many categories that you have, you're able to see through these different categories. So now let's move on to another question that says, how many product categories are in the products table? So in this case, we've been told the table. But I want to know how many product categories. So if you go to products, if you go to the products table, we see category. But I want to know how many of these categories do I have? How many of the unique categories do I have here? So let me just copy this. We want to identify the number of product categories that we have. So since we're interested in the number of the unique categories, then you use the count into brackets distinct. Then you include the column name, which in this case is the category column in the products table. From the products table. Okay. So we are selecting count distinct category from the products table. So as you know, when it brings out the output, it's going to bring out all these gibberish. So we use Alias to prevent that. So I can say num of categories. Well, I want to get the number of categories, or I can write product categories. So let me run this now. So we see that we have 5 product categories. Okay, we have 5 product categories. So that's just an example of how you can use distinct count. So remember, select distinct gives you the unique values, while count distinct counts the number of those unique values. So anytime you're interested in counting the number of unique values, use count distinct. But if you want to see the unique values that we have, just use select distance. All right, so let's move on to group by and order by. So I thought of we just taking some review of group by and order by because we need that on that having. So let's just refresh our memory, even though we've discussed that last week. So the question we have here is, what is the distribution of our customers by country? What's the distribution of our customers by country? So if you look at our customers table, you see that we have the country column. So we want to know how many of our customers belong to the different countries here. So that's where grouping comes in. Okay, so let me start to select from, we're taking it from our MySQL Launchpad schema, and we want the customers table in that schema. Okay. Now, what do I want to select from that table? I want the countries, right? Because I want to see the countries that my customers belong to, comma. Then I now want to count. So normally we usually use capital letter for functions and keywords. Sorry. But it is not compulsory. SQL is not case sensitive, neither is it. SQL is not case sensitive. Let me just say that. So you can use small letter, you can use capital letter. Some people write their queries all through with small letters. Some people write their queries with capital letters. But we like writing the keywords and function with capital letters so that that can help your code to be more readable. So I want to count the customer ID. Since the customer ID is the unique ID of each customer, so I can use that, but it doesn't matter. I can also just use star too, because I want to know how many entries belong to each country. So I can use star. Since I've been able to identify that my customer ID does not have any duplicates, so I can use count star. Yeah, or I use the customer ID. Okay, so that will help me to count it. So, but remember, just as we learned last week, once you have a colon and an aggregate function, okay, in your select statement, then you need to bring in group by. Because remember, like I stated earlier, these aggregate functions, they give you a single value. They go through the column and give you a single value. But since you are interested in counting the customers for each country, so you have to group it by country. So what this group by now does is it lets SQL split your table to the different countries that we have. Then the aggregate function cannot be applied to each group, then brought together for the final output. So let's run this. Yeah, so we have country. So this is our country and this is our count. Okay, but the count is not looking fine. So I can just use alias. I can say number of customers. Alias and run this. Okay, so now this is looking better. So from this table, what do we notice about the distribution of our customers? I'll appreciate some inputs here. What do you notice about the distribution of our customers?
We have more customers in the United States.
Yes, thank you so much. So that's, in fact, we can see that a huge proportion of our customers are from the United States. So depending on the insight you are trying to share, you might want to order this table, okay, such that it shows the customers, the number of customers, so that it arranges this table according to the amount of customers in the country, or it orders by the number of customers. So I'm going to include that order by, I'm going to include that order by clause now, order by, so I want it to order by the number of customers. So I can use my alias for order by, okay, because before order by, it will have done everything there. Order by is usually the last thing it does. So you can use your alias for order by, but you can't use alias in group by. Okay, or you can use alias in order by. So this is where we said that alias helps your code to be more readable, more understandable, and even easier to type. So instead of writing this function again, I can just use the alias. So let me run this. Okay, number of customers. Sorry. All right, so we have this. Okay, so when you use your order by, the default is that it arranges it in ascending order from the lowest to the highest. So, but I might be interested in showing it in descending order because I want to show the countries that have more clients first. So I now introduce the DESC keyword to order by, and let me run it again. So you can see that this is very intuitive now. USA with 338 customers, followed by Canada, followed by UK. So this is a case where you apply an aggregate function in the order by clause. So, but also you can arrange by a particular column. So for example, let's say I just want to arrange this column according to the countries in alphabetical order. So I can order by country. And I can remove this or use ASC. ASC is ascending order. Let me run this. So you have this in ascending order according to the country. So notice that order by, you can use a colon or you can order by the aggregate function. So by any case, we have been able to get the distribution of our customers by country. The next question is, for what reason are products returned most? So which reason, for what reason are products returned most? So remember that we already got the different reasons, the unique reasons why customers return products. But we want to know which one actually is the main reason or is the most outstanding reason why people or customers return products. So here you can still use your group by function. So for it, together we have to use the returns table and we use the reason column under the returns table. All right, so I want to select reasons because I'm interested in the reasons. Oh, what am I typing, please? So I want to select reason. Then I also want to select, I want to count the number of products that fall or the number of returns that fall in that category. I can say number of return. Okay, number of returns. Then from this, so that you always have to put a question mark. So when you are typing your SQL queries, you notice that if there's going to be an error, there's this red indicator here that shows you that there's going to be an error somewhere around here. And the reason is because of when you are selecting from different columns, you separate the columns using comma. So because I did not put the comma, it's saying that there's an error here already without running your SQL code. So let's do this. Oh, okay. Remember when you have a colon and an aggregate, you always have to use group by. Let me group by reason. All right. So we have the number of returns for each reason. So, but this is looking scattered. We can't easily get the reason here that has most return or that is responsible for most return. So we can order by. So in this case, we now order by the number of returns. So we order by the number of returns. Okay. Let's run this first. So we can see, oh, sorry, descending. We want it to be in descending order so that the most occurring reason will come up. So we can see that the most occurring reason for returning goods is defective because of the goods are defective. Okay, so since I am interested in the reason for which products are returned most, so I'm interested in this first one. So I can now introduce limits. Limit 1. So what limit 1 does is that you just want the first row. So if I run this, that returns the first row, which is now that we have revised group by and order by. So for having, we have this question. Which states have more than 10 customers? Which states have more than 10 customers? So we can get that from the customers table because we have states in the customers table. But we want to know which of these states have more than 10 customers. So let's go back to our query and just copy the customer table here. All right, so this time we're interested in the states and we want to count the number of customers. Oh, okay. All right, so we want to count all because we want to know how many customers are in each state. So we can alias this as number of customers. So if I run this, you see what I'm going to get. Oh, sorry, I always forget the group by. Group by states. You always have to keep group by when you have a colon and an aggregate function. All right, so we have this. We have the different states and the number of customers in these states. But we want to know which of these states have more than 10 customers. So this condition is going to work on this. Okay, so it's going to work on our aggregate function count because we are counting the number of customers, but we want to know how many of them or the states that have more than 10 customers. So this is where you now use having. So having, so these are our counts. asterisk should be what? Greater than 10. So that means we are saying states that have number of customers greater than 10. Okay, that's the meaning of this. So let's run this. Wow, and we find out that it's only two states, CO and NL, that have more than 10 customers. So, but now we now have a similar question. Which states in the US have more than 10 customers? Which states in the US have more than 10 customers? Because we understand that looking at the customers table, you see that these states belong to different countries. So, but we're interested in the one in US. Okay, so that means our code will be similar to this. Let me just copy this. Our code will be similar to this. But the only thing now is that we want states in the US. So we need to include country, because US is a country, of course. So we have to group by country and states. Okay. But we have to, if we run this, okay, let me just run this so you guys see what this will give us. So you see that this gives us the two states that had more than 10 customers and their country. So one is in US, one is in Canada. So I should have filtered out this Canada because I only want entries from US. So that's where comes in. Because I am filtering column wise. I'm filtering by a particular column where country equals USA. So I want the case where country is equals to USA. So I'm filtering out only US states in the US or entries in the US before it groups them by states and calculates the aggregates, then now follows this condition. So yeah, so the state CO, as we know, is from USA. So we can see our outputs now. This is the only state in USA that has more than 10 customers. It's even have just 11 customers. All right. Then the last question is, which products generated an average revenue of 3,000 and above? So this one is a little bit technical. I'll try to take us through it bit by bit. So we want to remember we're interested in products that generated an average revenue of this amount. So we'll go to the products table. Is that where we're going to get it? No. Go to others. Other item rather. Yeah, so because in the other item we have quantity, we have unit price, and we have discounts. So how do we now get our revenue? We calculate our revenue by multiplying the quantity that the customer bought by the unit price of the goods or products. But if there is a discount, then we have to subtract the discounts. So these discounts are decimal numbers. So like percentage, they are percentages. So you have to subtract from 100% so that you know the remaining amount that was made. Because since a discount was given. So let's say if I was supposed to sell something 100 naira. Okay. I was supposed to sell something 100 naira, but there's a discount of 20%. So what I'll just do is I'll do 100% minus 20%. That is 80%. So I'll now do 80% of 100 naira, and that will give me 80 naira. So it's 80 naira I'm going to sell that stuff. I'm going to get 80 naira for that stuff instead of 100 naira. So this is the formula that we use for revenue to be able to calculate the revenue. So since the question is asking for products, so I'm going to write my select, and I'm selecting from the orders table. The order, no other items, right? Order items table, this one. Okay. Yes. So that's the table I made. I am selecting the products ID, comma. Then I also want to calculate. The revenue using that formula. So I'll just copy this formula. So I have to use alias here. If not, my output will just have all this gibberish. So I can call this revenue. This is my revenue. So let me run this. Yeah, so you see the revenue for each product. But we have to recall that the orders item, the order item column gives the particular amount that a particular product was sold in that particular order. So that means that that product can be ordered several times. So that means here in this product ID column here, you can have a product ID repeating several times because it can be ordered several times. So I will want to get the average revenue, and as that's even what was required, average revenue. I want to get the average revenue for each product. So now I am bringing in an aggregate function, avg. I introduce brackets, then I also close my brackets. Okay, so this will now be average revenue. Average revenue. Now, since I have introduced an aggregate function, and I also have a colon here, I have to order by. And I'm ordering by product ID. So let's see what this gives us. Oh, I mean group by, please. Group by. I am grouping by, please. Group by, please. Okay, great. So now we have the average revenue for each product. Okay? We have the average revenue for each product. So, but we are interested in knowing the product that generated average revenue of 3,000 and above. So the condition is on the aggregate function, average revenue of 3,000 and above. So the condition is based on this. So in that case, I have to use my having function. So having these gates, Control C, greater than or equal to. I'm using greater than or equal to because I was told average revenue of 3,000 and above. So 3,000 is inclusive. All right, so let me run this now. So running this, we see these are the only product IDs that the average revenue is equal to or greater than 3,000. So you can say that's our top performing products. Okay. So later on in this course, you will see that we can actually get the actual product names. And because if you look at the product column, you have the product name and you have the product ID. So, but because we are working on the other items column that does not contain the column name, we can't get the column names yet. So, but there's something that we do, we call it join. So we can join these two columns together, these two tables rather together, and be able to get the column names of these particular products. So that we're able to better identify the products that are performing best in terms of revenue. All right. So this is all I have for us. I don't know if there's any question, probably any queries that you don't understand, or any other question that you might have.
Sir Isaiah, thank you so much for that, as in for today's presentation. Tomorrow we'll be glad to have you again. Thank you so much, sir.
It was a pleasure, sir. Thank you, everyone. So we'll see you tomorrow. Good night.